particular example, you have a hole here. So nothing is here, is empty. Now we want to reuse the calculation we had there and modify it somehow to include the effect of emptiness. So how can I do that? I know that the x bar is equal to sum x bar I, AI, divided by sum AI. This is the formula. So if I decompose this complex shape into subshapes, and I have the x bar location and the area formula for each subshape, I somehow add it together to get the x bar of the whole thing. But look, this part is empty, nothing is here. So how can I modify this formula to account for emptiness here?
Subtracted central.
Yeah. So what we do, all the formula is valid here, except when you have a hole, consider area to be negative. Consider area negative number. That's the point. So let's go ahead and do it. Again, I'll make my table shape AI x bar I AI times x bar I. Now I need to solve the first and the last column. So let's say shape 1, shape 2, and sum. So I would call this as shape 1, the blue A1, and the green A2. And now go ahead and fill out the table. So what's the A? And also don't forget that I'll put the coordinates. You have to choose the coordinate system. I'll put it right here, X, Y. But it's up to you. You can put it here. You can put it here. The final result after transfer it to unique coordinate system should be exactly the same. Okay? So for A1, what's the area of shape 1?
4/2.
4/2, which is 8. Area 2, this is shape 2.
Pi times 2.5
Whole square. Negative, because that's the whole. See? So I say pi times 0.25 square negative. Don't forget this. If you have a hole, the area contribution is negative. You just subtract, as you said, you just subtract away area. All right.
higher squared.
Now let's go to x bar 1. So what's the centroid of shape 1 independently if this was full solid?
2, 1.
Yeah, 2 and 1. So I just put Q. With respect to our coordinate system at the bottom left corner. You always compute this result with respect to the coordinate system you choose. Okay? Now x bar 2. The centroid of shape 2 with respect to here. X bar 2, give me the number. The centroid of shape 2 with respect to here.
3.
3.
1. 3, 1.
Yeah, 3. Now let's go and make the third column. We have first and second column. All I need is to compute the third column. The first one is obviously positive 16. The second one is negative 0.589. And this is inch squared, inch squared. Now, x bar is equal to this sum. This is sum. Sorry, we haven't made the sum yet. So here, sum of this column, AI, x bar I, which is 16 minus 16 minus 5, 8, 9, 15.4 inch cube. And sum of this, sum of AI, which is equal to 8 minus 7.80 sum AI. Now I'm ready just to plug it in the formula. So x bar is sum x bar y times a, which is this number 15.4 inches cubed divided by this number 7.8 inch squared. Let's do the division. 15.4 divided by 7.8. That's going to be this cancel out with this, so you get 1 inch. And the number is 1.98. Look what we got here. Let's say we didn't have a hole here. Let's say this was all filled all the way. Then what was the x bar if it was filled?
2.
Would be 2. But look, what I got is smaller than 2. That means the centroid, when we put a hole here, is going to shift to the left. Why? Because you have more area contribution here than here. It's empty. So that's the way you compute it. You mustn't get 2 or greater than 2. If you get anything greater than 2, then you say something is wrong in my computation. Okay? Let's do another formula, another shape, another. Before we go to another example, here I ask find x bar and y bar. Well, I got x bar, but what about y bar? Well, I can go ahead and do all this calculation. All I need is to replace x bar with y bar, and that's going to be ai times y bar I. And then you get a bunch of different numbers. But look, the y location, this is the x location, the y location should be
Smaller than half.
No.
Exactly half.
Exactly half.
Oh, well,
Because this is symmetric in y, you can fold it. Right? So the centroid is at the very center because it's all symmetric with respect to the y. So before even you make that table and do computation, you should say, I must get exactly 1. Right? From here to here. Because the centroid in the y direction, in the y, not the x. In the y is on this line. So it should be half of 2, which is 1. Exact 1. Right? Now, as a homework, it's optional, you don't have to turn it in. Go home and do the same computation, replace x bar I with y bar I, and then you should end up with y bar is equal to 1 inch exact, because it's symmetric. In fact, you can save your time in the exam or test. You can say X bar, I have no idea where the X bar is because it's not symmetric. If this circle was at the very center, then what was the X and Y? So it would be 2 and 1. But this circle is right here. So the centroid will shift to the left a little. But in the Y direction, again, this circle, you can fold it like that. It's symmetric, so it is 1. You see that? What time is it? 4?